All right, let's talk about something that every single person in security deals with, but almost no one has really cracked. It's that feeling you get every morning when you open your dashboard and it's just a wall of red. We're gonna get into that today.
It all boils down to this one question, right? Which one do you fix first? You've got literally thousands of alerts, all of them screaming critical, and you're supposed to pick one? Meanwhile, the attackers, they just need one path, one way in. So where do you even start?
I mean, we all use these tools. You know the names, they're amazing at what they do, which is finding stuff, but that's also the problem. They find so much stuff that you end up drowning in a sea of noise. Your teams are just getting flooded.
And that leads us to, well, kind of the dirty little secret of cybersecurity. We're all conditioned to chase these critical vulnerabilities. But are we even chasing the right things? And the answer, a lot of the time, is a hard no.
And this, right here, is the absolute truth of it. The huge majority of those high-severity alerts, they're never, ever going to be exploited in the wild. It's a tiny, tiny fraction that an attacker can actually chain together to build a real attack path, the kind that leads to a breach. The game isn't about finding everything, it's about finding those.
So you see the disconnect. On one side, you have the loud problem, just trying to patch everything with a high CVSS score. It keeps you busy, for sure, but the real problem, the truly dangerous one, is finding the handful of vulnerabilities that actually connect to each other and lead to a compromise. It's about being effective, not just busy.
So, if the problem is finding those few dangerous paths, how do you do it? Well, you need a different kind of tool. You need a map. And that's where this idea of Chakra ETI comes in. It's designed to give you clarity, not just more data.
So what is it? Think of it as a layer of intelligence that sits on top of your existing data. It takes all those raw vulnerabilities and uses something called a model context protocol to build a knowledge graph. Basically, it's not just telling you what the vulnerability is, it's adding all the context to tell you what it means.
Honestly, this is the perfect way to think about it. It's like Google Maps for your network. When you use Google Maps, it doesn't show you every single street and alley in the country, right? No, it shows you the best route from A to B. That's exactly what this does for attack paths.
And how it works is actually pretty straightforward. First, you just feed it your raw data, your CVE lists, your scanner exports, stuff like that. Then, ETI does all the heavy lifting. It analyzes everything, connecting the dots between the vulnerability, the type of weakness it is, and the tactics an attacker might use. It basically builds a theory of how an attack could happen. And what you get out isn't just a list, it's actual prioritized intelligence.
Now, I know you're probably thinking, hey, can't I just throw all this into ChatGPT and ask it to find the attack paths? And look, it's a totally fair question with all the AI hype right now. But there is a massive difference between a general-purpose AI and one that's purpose-built for security. This table really nails it. A general chatbot gives you unstructured text. You can ask it the same question twice and get two different answers. It's variable. And verifying it? Good luck. But Chakra ETI's approach is totally different. It gives you structured graph data. That means the output is deterministic, it's repeatable, and crucially, it's verifiable. For security, you need that precision. You can't work with maybe.
Okay, so theory is great, but let's see what this actually looks like in practice. We're going to take a single CVE, just one data point, and watch it transform into a full-blown attack path. This is really the aha moment.
So here's a real-world vulnerability. This is what your scanner sees. It's critical, it has a CVSS score of 9.8, which is basically as high as it gets, and the advice is, you guessed it, patch immediately. It's loud, it's scary, but it tells you nothing about the real risk. Now look at that exact same CVE through the lens of ETI. All of a sudden, we have so much context. We know it's a specific type of flaw, a buffer overflow. We know attackers use it for execution. We know it's on CISA's known exploited list, meaning, yep, bad guys are actively using this one. It's got a high probability of exploitation, and we even know the exact software it impacts. It's a completely different picture. And here's the magic. ETI takes that context and tells you the story. An attacker starts at asset A, uses this vulnerability to get code execution, steals some credentials, and then pivots over to your critical server B. It answers the one question that your scanner can't. Can an attacker actually get from here to there? And once you can see the path, well, it changes everything. The entire way you approach defense shifts. You go from trying to boil the ocean to focusing on a few key strategic points.
So let's go back to that dashboard we talked about. This is the before.
2,000 critical vulnerabilities, all screaming at you at once. It's analysis paralysis. It's completely overwhelming.
And this is the after. By applying that graph-based context, those 2,000 alerts get distilled down to just 40 vulnerabilities that actually link together to create a real potential attack path. Now that is something you can actually work with.
At the end of the day, it's this simple. One single graph that tells you the story of your risk is worth so much more than a spreadsheet with 1,000 rows of data. Context is everything.
And look, we have to start thinking this way because our adversaries already are. Attackers aren't manually looking for these things anymore. They're using AI to automate their reconnaissance and find these exploit chains way faster than any human team possibly could.
And that's the hard truth. You just can't fight an AI-driven attacker with a CSV export from your scanner. It's like bringing a spreadsheet to a fight. You have to fight fire with fire, or, in this case, fight graphs with graphs.
So that's really the question to leave you with. As the attackers get faster and smarter with AI, are your defenses keeping up? Is your strategy still based on tackling endless lists, or is it ready to understand the interconnected story of risk in your environment? It's definitely something to think about.